This will be our spring test number 6 from sections 1.1 through 7.3. We got through solving systems of equations using both substitution and combination or elimination. Number 1 says, which graph represents the following system of equations? You need to look at what each equation represents individually with your m and your b values. If you look at your first m value, it's 3, and your b value is 1. B values are usually the easiest ones to look for because that's where it crosses through the y-axis, or it's its y-intercept. So you're looking for equations that cross through 1. So as you look here, there's nothing that crosses through 1. You could immediately eliminate the first one. For b, there's an equation that crosses through 1. C, there's an equation crossing through 1. And D, there's an equation crossing through 1. So all three of those are still good. The second equation, look again at its y-intercept value. In C, it's -2. Where does all the equations cross through at -2? You don't have to check A because that one's already eliminated. We're crossing through at -2 here, at -2 here, and at -2 there. So the three of those are still in play. So what you want to check now, on the one that I have listed in red here, its slope is 3 or 3 over 1. First off, you can look and see that it's a positive slope. Notice 3's value, that m value is positive 3. That means that if it's positive slope, remember it's going uphill, not downhill. So this equation is still good because it's going uphill. However, this one is going downhill, so B can eliminate it now. And this one's still going uphill here. So C and D are still both in effect, are still good. Your m value for the second equation, notice there's nothing shown in front of x. That means there's a 1 understood there. Again, that one's a positive 1. So we're looking for a positive value of 1. Both of the equations for C and D, both of the blue equations are positive. They're both going uphill. So we're just looking for a value of going up 1 and to the right 1. So from this equation, or from this y-intercept, you're going up 1 and to the right 1. So that's the slope for that equation. Whereas when we're looking at this, the blue equation at D, you're going up 1, 2, 3, and over 1 to the right, up 3 and over 1. So D's slope would actually be 3 over 1, which is not 1 over 1, which we're looking for. So that eliminates, and there's other possible combinations or other methods to eliminate A, B, and D to get C. That's just the fastest one that we can come up with right now. Solving a proportion. What you want to do to solve proportions is cross multiply. Here's one. The bottom of the first one and the top of the second one's easy for most people. You cross multiply 5 times 2. That equals whatever you cross multiply the top of that one and the bottom of the one on the right. Now, but there's 2 terms on the top of the left one. So you need to make sure that you multiply 4 times both x and -8. You need to distribute it to both of them. That's the kicker for this one. 5 times 2 is easy. That's 10. But make sure you distribute 4 times x to get 4x and 4 times -8 to get -32. Once you have it in this form, it's easy for most people. Undo your subtraction of 32 by adding it. Do the same thing to this side. It's going to give you 42 equals 4x. And then get rid of 4 times something by dividing by 4. 4 doesn't go into 42 evenly, but the number 2 goes into both of them. 2 times 21 is 42, and 2 times 4 is 2. So x value will be 21 over 2. Or if you did it as a mixed number, it would be 10 and a half. Or if you did it as a decimal, it would be 10.5. Number 3, find a solution to the system of equations. Now, between last week and this week, we learned 3 different ways to find solutions to systems. The first one was the least effective way was to graph both of the equations. So if you're looking at a plane and you graph one equation and it looks like this, and you graph another one and it looks like this, Remember, this is the point where they both cross. That's the one that makes it a solution. That's the least effective, especially if you're freehanding it. We also learned two other methods this week. We learned how to substitute values in, and we learned how to use elimination or combination. This system will actually lend itself okay to use substitution. And the way you can determine that is because if you look at this variable here, plus y, its coefficient is 1. So that means that's an easy one to get y by itself. So move negative 5x on over to the right side by adding 5x, because that's the inverse of minus 5x. Do the same to the right to balance it. And that'll leave you with y equals 5x positive 4. If you wrote 4x, if you wrote 4 plus 5x, that would be correct as well. But most of us are conditioned to write in mx plus b form. So this gives us the value of y. We worked on this yesterday. 5x plus 4. Take that equation, and in the other equation, in this case it happens to be the one on top, 3x plus 2y equals negative 5. Plug that value in place. It says y equals this. So in place of y, plug this in. So now instead of saying 3x plus 2y, 3x is still the same, plus 2, but now it's not y anymore. It's the value we got for y, which is in parentheses, which is important in this case, 5x plus 4. The reason it's important is because if you don't include the parentheses, you may only multiply the 2 by 5x and forget to distribute it to the 4 as well. That's still just like the regular equation, equals negative 5. So the only thing we did is we substituted in that value 5x plus 4. Now what you need to do is you need to make sure you distribute 2 times 5x is 10x, and times 4 is positive 8. Bring everything else down. It was positive 10x, so plus. Combine your like terms. You have 3x and you have positive 10x. Put those two together and you get 13x. Bring everything else down. Plus 8 equals negative 5. Get rid of plus 8 by subtracting it. You subtract it on the left, do the same on the right. 13x equals negative 13. And then get rid of 13 times something by dividing by 13. If you do it on the left, do it on the right as well. And x equals negative 1. Now you have a value for x. If you were to graph them, they would intersect where x's value is negative 1. But we still need a y value. So you need to take this value, negative 1, and you need to bring it back up here, and it says x equals that. Plug it in place of x. So instead of y equals 5 times x plus 4, now you have y equals 5 times, we have x's value, which is negative 1. 5 times negative 1 is negative 5 plus 4. And negative 5 plus 4, y's value equals negative 1. So you have x's value is negative 1 and y's value is negative 1. Once you have both of the values, an ordered pair is going to be x comma y. So list it as x, which is negative 1, comma y, which is negative 1. Here's your answer to the solution of the system of equations. Negative 1, negative 1. Number 4, it says solve the following system of equations by graphing. Now, if you were to graph these, especially when you're freehanding it, it's going to be kind of tough. But this is how we're going to do it if you do graph them. You need to make sure you put it into a form that you can graph. So if you look at the first equation, negative 4x plus 3y equals negative 12, you wanted to say something that you can graph, y equals mx plus b. Remember, that is slope-intercept form, y equals mx plus b. So move negative 4x over by adding 4x. If you do it on the left, make sure you add 4x on the right. That leaves you with positive 3y on the left equals positive 4x negative 12 on the right. Get rid of 3 times something by dividing by 3. If you do it on the left, make sure you do it by everything on the right. Y equals 4 over 3 x minus 4. That's in mx plus b form. We're going to use that to graph because its m value is 4 over 3 and its b value is negative 4. We have to do the same thing to the other equation. Negative 2x plus 3y equals negative 18. Go a little quicker through this one. Move negative 2x over by adding it. That leaves you with 3y equals positive 2x minus 18. And to get rid of 3 times y by dividing by 3. And that leaves you with y equals 2 over 3x minus 6. Where your m value for this one is 2 over 3. And your b value is negative 6. Again, mx plus b. Both of those tell you where to graph those equations. So on one plane, your first equation tells you to begin at negative 4. Just a few things to where we can start. Our first equation says begin at negative 1, 2, 3, 4. Remember, it's always your y-axis you begin at because it's your y-intercept. Your slope is 4 over 3. That tells us go up 4 and right 3. So up 4 and to the right 3 times. And we would draw a straight line through those as best we can. The other equation says to begin at negative 6. So again, on the y-axis, begin at negative 6. That one tells us to go up 2 and to the right 3 times. Up 2 and to the right 3 times. So that equation, as we look at it, is going to look like that. Again, the point that we're interested in is where they intersect each other. And when you're freehanding graphs, it's almost impossible to come up with a perfect spot where they intersect. But what you need to be interested in is this is the point where they're going to intersect each other. And when you have a graph paper or you have graphs to choose from, like on a test tomorrow, the spot they intersect is going to be the spot that you name as the solution. Just like on number 3, we named the solution. Says, what's the solution of the system of equations? This one already has y isolated for you. Y equals x plus 2 and y equals negative x minus 8. So this absolutely lends itself well to substitution. But if you also look at it, you can see that your x and your negative x are stacked on top of each other. Those are opposite terms. So if you combine these to use elimination, and put y and y together or combine those two, you get 2y. Equals, if you combine x and negative x together, you get 0x or no x's. They cancel each other out. And 2 and negative 8, when you combine those, you get negative 6. So you have an equation that says 2y equals negative 6. Get rid of 2 times y by dividing. Do the same on the right. Y equals negative 3. So we were able to get y's value relatively quickly in that sense. Take y equals negative 3 and choose either equation to plug it in. Looks like it'll work a little bit better in the first equation, or most of us are more comfortable with positive numbers instead of negative. So instead of y equals x plus 2, we'll take that value in place of y and we'll plug in negative 3 in place of y. So negative 3 equals x plus 2. Get rid of plus 2 by subtracting it. Do the same on the left. Negative 3 minus 2, think of a number line if you ever get stuck with this. Remember, you add 0, negative 1, 2 is where you start. If you you start at negative 3. If you're subtracting 2 more, you're going to go your numbers subtracting or 2 more to the left, 1, 2. So you'll be at negative 5. So negative 5 equals x. So you have a value for y and a value for x written as an ordered pair. Remember, it's always x comma y. You need 2 numbers. X's value is negative 5 and y's value is negative 3. and we'll pick up number 6 on the next video.